Hello and welcome back. Today the topic is the Vespa PX stator plate. This 12-volt stator plate was installed ex-works in the PK and the PX models, and it's now also installed in the early small frames, large and wide frames. The structure is always the same and varies only slightly. As you know, we need three things to start or fire up the Vespa, which is gas, ignition and compression. Today I will show you a part of the ignition, the stator plate, how it's working and how do we test the whole thing. Before we start, I'm gonna talk about the key components, which is the stator. The ignition baseplate contains coils and the pickup sensor, this one, detects the current timing for the ignition park. The coils, 1, 2, 3, 4, 5 coils, provide stable power for lights and other components. And with one special coil, which is this one, this coil is especially for the ignition park. This green cable here will go directly into the SDE. Yeah. How it works: when the engine is started, the flywheel rotates clockwise, which contains built-in magnets. These magnets generate a changing magnetic field. These coils here on the stator plate generate alternated current AC power as the flywheel magnetic field passes over them. These current powers both the ignition system and the 12-volt electrical systems. In detail, we have 4 coils, 1, 2, 3, 4 coils for the lights and other components. Yeah, these 4 cables here, and 1 cable for the ignition, the green one. Now the pickup is a sensor. This one detects when a specific magnetic flywheel passes by. It sends a signal to the SDE, which determines the exact ignition timing. And the white one is ground. Yeah. So for us to test are these 3 cable and these 4 cable. I'm going to show you in another video what is about the lights and other electronic components. Measuring with the multimeter. So what we're going to do first is we test the ground. Therefore we move on the connection. So good. Then we take the white one. The white is the ground. Good. And we are checking if there's a signal with the ground. Yeah. And then as well we check if the other cables are connected. Yeah, correct. No, good, that's okay. Then we move on to ohm, 2000 ohm. We take the red, the white one, red and white. And the amount must be between 100 ohm plus minus. As you can see, it's 94, that's great. So we can check directly red and green. This must be between 500 and 600 ohm. It's 478. Yeah. And then we check again green and white. Green and white. This must be around 500. It's as well okay. A little bit low, but it's still okay. Yeah. With these measurements you can quickly determine if the stator plate is defective or functioning correctly. If the value is or are incorrect, replace the entire stator plate is usually the best way. One topic I would like to highlight is aging and brittleness. Over time, plasticizers evaporate, causing cables to become hard and brittle. This can lead to cracks, reducing connectivity and safety. Tightly bundled cables like this one here can increase the risk of short circuits and cracks. And if you really need to replace a cable, always go for silicon cables, high resistant to heat and chemicals. Plasticizers make cables flexible at the first time, but over time they can cause serious issues. It's always best to choose high quality cables with durable materials. Again, thanks for watching the video. See you next time. Bye bye.